start. Share my screen with the peoples. Boom, there's everyone. That's lovely. So if you can begin to say goodbye to me, but don't run away. Just take yourself off video, but keep yourself on microphone so we can get involved in the lesson together. All right. So see you guys quite soon. All right. So I need to ask Faris to turn his video off, and Akshan as well, turn your video off so we can do this. All right. But do listen in, please. Thank you. So this is what we did last time, Harrison, etc. We talked about that one. You plotted that one. You plotted that one. Akshan, this was definitely a negative correlation, because as the number of days until the festival increases, fewer and fewer tickets will be sold, because most of them will be getting more and more sold. So there's less around, you see. Okay, that's that done. The reason I chose 4D was because I wanted you to handle decimals, and what you did was beautiful. This was a really strong negative correlation. Clearly, the higher the mountain, the lower the temperature at the summit, at the peak. Higher you are, the colder it is. So today, and also, by the way, many of you actually drew lines of best fit, which is lovely, but the question didn't ask you to do that, because the whole point of a line of best fit is that so you can read off it later on if they want you to find out some stuff. So let me show you an example of where finding out stuff is relevant. If this thing would just refocus before I break it. Good. So in the next part of the book, they actually do introduce lines of best fit. This is why they're useful. I'm on page 253. That's where I am. You can see it in your book, or you can see it on the screen, but it's not that clear on the screen, I don't think. So let me just go with that and try and read it myself. So if a scattergram shows a correlation, so if it does, then you can draw a line of best fit, because that shows the relationship more clearly. I have to stop tinkering. So the scatter graph shows the marks scored by pupils in maths and in science. So Yusuf, even this book recognises there would be some sort of weak positive correlation between your score in maths and your score in science. Generally, the technically minded people who like numbers and science tend to grow together. So we've got a weak positive correlation. Now, what you won't see from this, unless you've got your book in front of you, is that Jimmy's score in his science is 34 marks. He missed his maths test. Can the teacher reliably estimate his marks for the maths test? The answer is not bad. So if you go across the 34 on the x-axis where the science mark is, you then draw a dotted line up to the line of best fit and turn left. Now, you won't see it on screen, but there is a little arrow pointing up and there's a little arrow pointing left. So according to this, if Jimmy gets 34 in his science, he should get around 30 marks for his maths, because it follows this trend. Is that okay? Okay, that's Harrison. Good, thank you. Yes, so it's reliable, but only if there's a correlation. If there's no relationship, you can draw lines randomly anywhere, and it means nothing. So that is why this next little bit is important, because now we're going to get you to actually read off your own line of best fit, and all your answers will be slightly different because you might not judge it exactly the same, all of you. So let's look at exercise 1 together before I let you run away and do your 1 or 2 questions. Is that line of best fit any good? Why not? Why not? It's clearly a positive correlation, not a negative correlation. Is that a line of best fit? It's not a straight line. It's squiggly. They tried to join a few points. It's not right. That one's ridiculous. They've joined every point. What about this one? I think that's quite good, actually, because it's sort of passing through the middle of The points is a positive correlation, and they've drawn it right. Now we have to judge whether they've drawn a decent line of best fit or not. What do you think to that? Is that any good? It's right through the middle of the point. It's a very, very good line of best fit. What about that line of best fit? There's no correlation. Why would you even draw a line of best fit to show a relationship that doesn't exist between these two unnamed variables? Makes no sense. Now, here's an attempt. What's your comment on that?
No, because it's not the middle of any of the dots.
Yeah, good.
It doesn't go through any of the points.
Thanks, Faris, and the other sister who spoke. Yeah, it should go through the middle of the point. There's definitely a negative correlation. Do you remember from your Year 8 knowledge from before what that point might be called? That
Is it like anomaly or something? Anomaly, isn't it?
Yeah, if you're in science, you call it an anomalous result. In mathematics, we call it an outlier. It's lying outside of the expected range of data. Do you see that? It's not that.
Yeah.
It's not that this person has plotted the point incorrectly. No, that's not it at all. It's an anomalous result. This is a science experiment, but actually this person is not within the expected data range. For example, if this was like shoe size and glove size like we've had before, this person might have really big hands and really big feet and hush please. So is that all right? It's not wrongly plotted, it's just it's not within the expected data range. I can't think of one that fits. Maybe as the temperature increases, the number of coats sold in the market or from shops decreases because it's getting summery. This guy, it's nice and hot and he buys lots of, warm clothing, say. Not normal, it's outside the data range. Now, let me just turn over to the next page. Can I just focus your mind on this question? Now, can I ask Yasmin to read to us, please?
In an experiment, people were asked how many hours a week they spent exercising, and their BMI, body mass index, was recorded. The results are shown on the scatter graph. A line of best fit has been drawn.
Because there's clearly a relationship. A?
Describe the correlation shown by the scatter graph.
Right, somebody call that one out.
Negative correlation.
Very, very good. It's clearly a negative correlation. Now, Frank spends 4 hours a week doing these exercises. You, Year 8, use the line of best fit to predict his body mass index. What do you plan to do?
22.
What do you plan to do to evidence that?
Just to line up from 4 hours, and when it hits the line of best fit, you then go left.
Yeah, of
BMI.
course, I'm not expecting anybody to draw question 3. That's really silly. But clearly, had you been presented with this on paper, then you go up, left, arrow, arrow, 22, body mass index. I don't know what the units are, but anyway, clearly, the more hours spent exercising, the more fat you lose, your body mass index goes down. Okay, now it's really all I want you to do is question 3, which we've done, which you don't actually draw out, Harrison, you just answer the question. Now question 4, thanks Harrison, so question 4 is the one you actually have to physically do and draw, and the numbers aren't that kind. So Ali and Kiara are doing an experiment to find out how long different potatoes take to bake perfectly. I don't know how you judge that. I suppose you stab it with this little stabby thing.
Yeah.
I guess, but I don't know how you can quantify that. So there it is. They've done a grid for you. Now, DR and anyone else, don't do it that small. That's no bigger than a stamp you put on a letter. Sort of, slightly bigger, but anyway. No, just you can do the squiggly line because no potatoes are like 0 grams. but time could be 0 time, I guess. They started from 0, so I guess you should do the same. So I'll spread out this axis really long and spread this out really wide as well. Otherwise, you end up with a tiny little thing and you won't be able to read off it. So you plot these points. So the first one is 150 across and 30 up, which is really hard to judge. You can construct your own scale, whatever fits best for you. And the next one is 180 along, which is, like, I reckon, 2 squares from the left, and 40 up, again, which is hard to judge. I think that every one of these little squares is 5 minutes, because it's from 25 to 50. Oh, it's not 5, is it? What is it? That's difficult. 5 squares is 20. Yeah, each little square is worth 5. Ugh. So every little square is actually 5 minutes. 5, 10, 15, yeah, 25. That's tricky. Mind you, you've got a much bigger book than this, so you can expand it as big as you want since you're only doing one graph. Okay, and then you draw your line of best fit. Now, judging by the data alone, just look at the data. Can you tell us what sort of correlation we're going to get? And explain it as well. Just by looking at the numbers, without even plotting, what sort of correlation would you expect?
Positive.
Yeah. Can somebody explain that, Dion?
It's because as the cooking time goes up,
No. It's not about the cooking time. Somebody else speak.
The heavier the potato, the longer cooking time.
Say again, please.
The heavier the potato, the longer cooking time.
I think so. You don't start with the cooking time, dear. You start with the potato. So here we go. 150 gram potato should take 30 minutes. Look at this one. 180, a bigger potato, more time. A 250 gram potato, even more time. Can you see that? So you need to plot. Yeah, so be very careful, dear, how you said that. Clearly, it's going to be a positive correlation. And then, Harrison, Akshan, anyone else, use your line of best fit to estimate how long a 300 gram potato will take to bake. So I'm going to reckon you do something like that. So you go along to 300, draw in the line, hit your line of best fit, and do what Sid says, turn left. Is that all right? And read off that number. Okay? Now, that's all I need you to do. I've posted the task on Show My Homework along with this video invite. So just do that one. You answer that and you answer that. Don't draw anything. For this one, you take your time and draw. And as soon as you've done it, please would you send it to me so we don't crash into our other lesson.